In this video, we're going to look at Wt equals W0 times 5 to the power of negative 0.00025. So this is modeling a massive radioactive substance that's decaying after 10 years. Now, what we're going to do is we're going to find the initial mass. So initial. So that is when T equals 0. Now when T equals 0, so we're going to have W0, that's going to equal W0. That's the initial. Because 5 to the, what's T there? 5 to the power of 0 is equal to 1. Because if I make this T here 0, it's going to make all of that 0. And anything to the power of 0 is 1. So our initial is W0. Now, if I want to find the weight after 100 years, that's T equals 100 years. So W100 equals W0 times 5 to the power of negative 0.0025 times 100 equals W0 times 5 to the power of negative 0.25, which equals 0.0. Sorry, not 0.0. Put that in your calculator. You get 0.6687 of W0. Okay, 5 to the power of negative 0.25 is 0.6687. Now, if we put that into a percentage, that's 66.87% of W0. Okay? We're just timesing by 100 to put it to a percentage. Now, if I wanted to know what that was after 600 years, because we don't 600, because we don't know the initial weight, we don't know the weight, so we know it's 66.87% of the original weight. So once we find that, we can work it out quite easily. So then we have W0 times 5 to the power of negative 0.0025 times 600. Put that into your calculator and you'll get W0 times 0.089. And that would be 8.9% of W0. Okay, like we did before, we multiplied it. Now, if you're asked to graph that, let's make some space here and graph it. So there are percentages. So obviously we need our X and Y axes. So this will be time. This will be weight. Now, where do we start? Well, our initial at time 0 will be 100%. Okay, we got 50%, and we got 100, 200, 300, 400, 500, 600 years. Make sure you use a ruler and your scale is constant, of course. So we have 100%. So that's it there, 100%. After 100 years, it's 66.87%, so that's about here. All right, after 600 years, it's 8.9%, so it's going to obviously be down here. So you can see we have a decay. And there's our graph. So it's just a sketch. You'd obviously use a ruler and use the information. We're converting that decimal to a percentage by timesing it by 100. So we're just finding the percentage of the initial weight. We don't know the initial, so we do what we can with it. It's just like algebra, just like X. If it was an X, an unknown, we just leave it there and do what we can.